Hello students, welcome to my channel Math Magic. Me Provish Sarkar. Today I will discuss about the chapter determinants. Okay, if my video helps your study, share my video all of your friends and like and comments on my video and subscribe my channel. Okay, so let's start. Let's start determinants. Okay, suppose we take a matrix A is equal to square matrix, obviously A11, A12, A21, A22. Okay, so determinant of matrix A we write as determinant A or determinant A is equal to determinant A11, A12, A21, A23. Okay, so A11, A12, A21, A23 all are called the elements of that determinant. Okay, already I will discuss in my previous video. Already I discussed all the elements. Okay, now how to solve this determinant? See, therefore A11 into A23 minus A12 into A21. Okay, after solving this we get the result of that determinant. Okay, now give an example. See, suppose here is a determinant 2, 3, 5, 6. Okay, so how to solve this? This is 2 into 2 determinant, that means order 2. So how to solve it? See, 2 into 6 minus 3 into 5. So 12 minus 15. So the answer is minus 3. Okay. So determinant of this function is answer is minus 3. Same as we do 3 into 3 determinant. Okay. So give an example, 3 into 3, that means order 3 determinant. Okay. See how. Suppose determinant A, determinant we take any determinant, order 3, order is 3, 3 minus 4 5, 3 minus 4 5. Okay, then is 1 1 minus 2, 1 1 minus 2. After that 2 3 1, 2 3 1. Okay, we take a determinant whose order is 3. How to solve this? See carefully. 3 into determinant deleting ith row and jth column. That means 3 1. This element is 3 1 1, A11. That means deleting first row first column. So 1 remaining is 1 minus 2 3 1. Okay, then minus of minus 4. Okay, then minus 4. That is the order of this element 1 into 2. That means first row second column. So deleting ith row jth column, that means first row second column, we get 1 minus 2 2 1. Okay, then plus 5 into determinant. Okay, first is plus, then minus, then plus 5 into 5, that means this element is A13. So deleting 1 first row third column, so we get 1 1 2 3. Okay, now solve this. 3 into 1 into 1 1 minus 3 to the 6 minus 6, that means plus 6. Okay, minus minus plus, so 4 into, okay, minus minus become plus, 4 into, here is 1 1 the 1 minus minus 2 minus 2 into 2, that is minus 4, so plus 4. Okay, then 5 into 3 1 the 3 minus 2 1 the 2. Got it? So calculate 3 into 7 plus 4 into 5 plus 5 into 1. So 3 7 the 21 plus 4 5 the 20 plus 5 1 the 5. So 21 20 41, 41 plus 5, that is 46. This is the result of that determinant. Okay. So hope all of you understood. Next, another important things. Okay. See carefully. Next is minor and cofactor. Minor and cofactor. Okay, so first is minor. Suppose we take this element. Okay, this element, that means we write this way: A11, A12, A13, then A21, A22, A23, then is A31, A32, A33, all are the elements. Okay, so suppose we take any element, that means suppose A21, we take A21. So minor of this element A21, okay, determinant of deleting ith row and jth column, that is the minor of that element. Okay, so we take suppose A21, here is A21 is 1. Okay, so suppose minor indicate as Mij. Okay, that means here is M21. Okay, so minor of this element is deleting ith row and jth column. Ith row, that means I is here is 2, so 2th row, second row, and deleting second row and first column. Okay, so deleting second row and first column, we get -4 5, -4 5, then 3 1. Okay, so this is the minor of that element, that is A21. Okay, you find all the minor of all the element of that determinant. The process is same. How we find the minor of any element of that determinant? Okay, first of all, determinant by deleting ith row and jth column, we get the minor of that element. Okay, so what is the minor of that element? That is A12. Okay, A12, minor of that element A12 equal to -4 into 1 minus 5 into 3. So -4 into 1, that is -4, 5 into 3, 15. So -4 minus 15, that is -19. So minor of A21, the minor of that element A21 is -19. This is the minor, very important. Then cofactor. Okay, cofactor is cofactor equal to, in cofactor write as capital Aij, that is indication of cofactor. Okay, cofactor equal to, how we find the cofactor? That means -1 whole to the power I plus j into minor ij. Okay, that means first of all we find the minor, after that multiply minor with -1 whole to the power I plus j, we get the cofactor of that element. Okay, see, suppose we find the minor A21, we find the cofactor of A21, that means that element. Okay, so what is the minor of that element? That is -19, already we get. Now the cofactor equal to -1 whole to the power I plus j, that means I plus j means first is I, second one is j. Okay, I means 2 plus j means 1, then minor, that is -19. Okay, so -1 whole to the power 3, 2 plus 1, that is 3. All of you know, -1 to the power even number becomes positive, -1 to the power odd number become negative. Okay, so -1 whole to the power 3, that is minus. So minus of -19, that is +19. That is the cofactor of the element A21. Okay, in the applying same process, you find the minor and cofactor all the elements of that determinant. Okay, okay, next. Okay, now give two examples. Okay, see carefully. Example number 1. Find the value of x if x square x1, then 0 to 1, 0 to 1, then 314 is equal to 28. Okay, now this determinant, result of this determinant equal to 28. Now the question is, find the value of x. Okay, see how to solve this. X square into determinant eliminating this row and this column, so 2114. Okay, then minus x determinant eliminating this row and this column, 0134, 0134. Okay, then plus 1 into same, eliminate first row third column, 0231, 0231 is equal to 28. Okay, is equal to 28. Now here is x square into 4 to the 8 minus 1 1 the 1. So 8 minus 1, that is 7. so 7x square. After that minus, okay, x into 0 minus 3, that means plus 3x, then plus 1 into 0 minus 3 to the 6, that is minus 6, is equal to 28. Okay, after that 7x square plus 3x, 28 come on the left side, so minus 28, so minus 6 minus 20, that is minus 6 minus 20, that is 34, is equal to 0. So after eliminating this, we get an quadratic equation, that is 7x square plus 3x minus 34 is equal to 0. Okay, so by using middle term factor, we get x minus 2 into 7x, x minus 2 into 7x plus 17 is equal to 0. Okay, so product of two number is 0, then one of them must be 0. So we can write x minus 2 is equal to 0 or x equal to 2, the value of x equal to 2, or another 7x plus 17 is equal to 0, or 7x is equal to minus 17, or x is equal to minus 17 divided by 7. Okay, so the value of x is 2 and minus 17 by 7. Okay, got it? See carefully. Come to the next example, example number 2. See carefully, example number 2. Given that a determinant that is given 5, 3, 8, 2, 0, 1, 5, 3, 8, 2, 0, 1, then 1, 2, 3, 1, 2, 3. Okay, now listen the question. The question is using cofactors of element of the second row, using cofactor of the element of the second row. Okay, second row. Find out the determinant of this. Okay, find out the determinant of this. Now see, we write same using element a11, a12, a13, then a21, a22, a23, then a31, then a32, then a33. Okay, now using second row. Okay, by using second row, cofactor of the elements of the second row. See, second row, that means a21, that means a capital A21, cofactor of second row first column, that is capital A21. Okay, how to find minus 1 whole to the power 2 plus 1 into determinant of eliminating second row first column. Okay, second row first column. So second row first column. So 3, 8, 2, 3. 3, 8, 2, 3. Okay, got it? So see, minus 1 whole to the power 2 plus 1, that is 3. So minus 1 whole to the power 3, odd number. 3 is the odd number, so minus remain minus. Okay, now see, here 3 3 is 9, minus 8 to the 16. So 9 minus 16, minus 7, here is minus, so plus 7. Got it? Okay, that means this element A21, the cofactor of this element capital A21 is equal to minus 1 whole to the power 2 plus 1 into determinant of this, that means 7 we get. Then capital A22, okay, so capital A22, that means minus 1 whole to the power 2 plus 2 determinant of 2, that means this element, this eliminating second row second column, so we get 5 8 1 3, 5 8 1 3. Okay, so what is the answer? See carefully, minus 1 whole to the power 4, minus 1 whole to the power 4, that is plus 1 or 1. Okay, now 5 3 is 15, minus 8 1 is 8, so 15 minus 8, 7. Okay, so only 7 here. Okay, now capital A 2 3, that means second row third column, so eliminating second row third column, minus 1 whole to the power 2 plus 3, then determinant of 5 3 1 2, 5 3 1 2. Okay, 5 3 1 2. Now see, minus 1 whole to the power 2 plus 3 whole to the power 5 minus 1 whole to the power 5, that means minus remain minus. Here is 5 to the 10 minus 3, that is 7, so minus 7. Okay, now the determinant of this, okay, by using the cofactor of the second row. Okay, see, determinant equal to capital A 21 into capital A 21 plus A 22 into capital A 22 plus A 23 into capital A 23. Clear? Okay, eliminant into cofactor of that element. Okay, now already we find out the cofactor of that element. Okay, now capital as element, that means A21, that is 2, so 2 into 7. Okay, plus capital A22, that is 0, 0 into A22, that is 7. Okay, then plus A23, that is 1, 1 into, here is minus 7. Okay, so 7 to the 14 plus 0 minus 7. So what is the answer? 7. So determinant of this function is 7 using the cofactor of the second row. Clear? See carefully. Now come to the next, that is properties of the determinant. Okay, properties of the determinant. See carefully, listen. Properties of the determinant. Okay, first property. See, if the any row or any column, all the elements of a determinant is 0, then the result of that determinant or answer of this determinant is 0. Okay, I repeat, property number 1, if all the elements of any row and any column is 0, then the answer of the determinant or result of the determinant is 0. Okay, this is property number 1. Now property number 2. See carefully. If in a principal diagonal and any side of the principal diagonal all the element is 0, then the result of that determinant is the product of all the product of the elements of all the principal diagonals. See, suppose, give an example. Suppose here 2, 3, 5. Here is 0, 5, 1. Then 0, 0, 3. Okay, now this is the principal diagonal 2, 5, 3. This is the principal diagonal. Look, in all the element of any side of principal diagonal is 0. Here in the below side 1, 2, 3, all the element is 0. Okay, so the answer is 2 into 5 into 3. The answer is product of all the elements of that determinant of the principal diagonal. That means the answer is 2 into 5 into 3. That is 30. Okay, answer of this determinant equal to 30. Okay, now come to the third property. Okay, see, listen. Property number 3. If the row or column are interchanged, if row and column are interchanged, then the result of the determinant remains same. That means a determinant of A is any determinant of A and determinant of A transpose. Interchanging row and column, we get A transpose. So determinant of A and determinant of A transpose are same. Okay, come to the next, that is property number 4. Property number 4, if 2 row or 2 column, all the element are same, that means 2 row or 2 column of a determinant are identical, then the result of the determinant or answer of the determinant is 0. Okay, this is property number 4. And now property identical means all the elements are same to same. Okay, now property number 5, this is very important. Property number 5, listen carefully. Property number 5, the sum of the products of elements, the sum of the products of the element of any determinant, the sum of the product of any row or column with the cofactor, the sum of the product of any of elements of any row or column with the cofactor of the corresponding elements of some other row or column is 0. Okay, given, see an example. Suppose we write A11, A12, A13, then A21, A22, then A23, then A31, A32, A33. Okay, this is a determinant. Now, the sum of the product of all the elements of any row is and the cofactor of any other row, cofactor of the corresponding elements of any other row equal to 0. Okay, see, suppose A11, take first row A11 and take cofactor of the third row, that means A31 plus A12, then A capital A 3 2 plus A 1 3, then capital A 3 3 is equal to 0. So we take the element of the first row, element of the all the elements of the first row and the cofactor of the third row. Okay. So any row, we take second row and third row, any row. Okay. Now here is the example: the sum of the products of element of the first row with the cofactor of the corresponding element of the third row is 0. Got it? Now give some example. Okay, using property. Now give some example using property. Okay. Now example number 1. See. Example number 1. Using property, solve 1 BC into B plus C, then 1 CA into C plus A, then 1 AB, then AB into A plus B. Okay, find the determinant by using property. Okay, now see how to solve this. See, in R1 we multiply by A. In R1 all the elements we multiply by A. In R2 row 2 we multiply all the elements by B, and R3, that means row 3, multiply all the elements by C. See, 1 by A into 1 by B into 1 by C. So in R1 multiply all the elements by A, that is A, then ABC, then ABC, B plus C. In second row multiply with B, then ABC, then ABC into C plus A. Okay, then C, then ABC, then ABC into A plus B. Okay, got it? So R1 equal to A R1, R2 equal to B R2, R3 equal to C R3. Okay, now see, take common ABC from second column as well as third column. Okay, both the column, look, second column and third column, ABC is common factor. So take ABC from second column and third column. So ABC into ABC divided by ABC already there. So A1, then B plus C, then B, then 1, then C plus A, then C, then 1, then A plus B. Got it? Now 1 ABC cancel. So ABC into C. Now we do column 3 equal to column 3 plus column 1. Okay, we do column 3 equal to column 3 plus column 1. So see, A, then 1, then A plus B plus C, then B, 1 A plus B plus C, then C, 1 A plus B plus C. Okay, now write what we will do, that is C3 equal to C3 plus C1. Okay, in C3 we do C3 plus C1. Okay, now see, A plus B plus C in the row column 3 are same. So take A plus B plus C as common from the third column. So we get ABC, then A plus B plus C. After that A, B, C, 1, 1, 1, then 1, 1, 1. Okay. Now see, column 3 and column 2, column 2 and column 3 both are identical. That means all the elements on column 2 and all the elements on column 3 are equal. So that is why by using property, if all the elements side by side, row or column are identical, then the result of the determinant is 0. Okay. So we write ABC into A plus B plus C into 0. So the result of the whole determinant is 0. Okay. See carefully. Come to the next example. See carefully. Then example number 2. Another important question, example number 2. Okay, by using property determinant a minus b minus c, a minus b minus c, 2a 2b. Okay, then a minus b minus, then 2b, then b minus c minus a, here is 2b. Okay, then 2c, then 2c, here is c minus a minus b. Okay, solve solve the determinant by using property. Okay, now see how to solve this. Okay, first of all we do R1 in row 1, R1 plus R2 plus R3. That means in row 1 we calculate R1 plus R2 plus R3. So what happened? So in row 1 R1 plus R2 plus R3. Okay, so A plus B plus C in the row 1. Here is also 2A plus B minus C minus A plus 2C. Okay, so A plus B plus C. Here is also A plus B plus C. Okay, row 1 equal to, in row 1 equal to row 1 plus row 2 plus row 3. Clear? So to be, here is, sorry, in first there is 2A, not 2B. Okay, so 2A, 2B, 2C. Listen carefully, 2A, not 2B. Now, in second row and third row remain same. That is 2B, B minus C minus A, 2B, then 2C, then 2C. Here is C minus A minus B. Okay, so write what we will do. That is row 1 equal to R1 plus R2 plus R3. Got it? Now see, A plus B plus C common from all first row. So take A plus B plus C, take out common from the first row. So we get A plus B plus C. Then 1, 1, 1. Then 2B. Then B minus C minus A. Then 2B. Then 2C. 2C. Then C minus A minus B. Now what we will do? Then C2 equal to C2 minus C1. Column 2 equal to column 2 minus column 1. And column 3 equal to column 3 minus column 1. Okay, see carefully. A plus B plus C. Okay, then first column remains same, 1, 2B, 2C. Then second column minus first column. So 1 minus 1, that is 0. Now this minus this. So we get minus A, minus B, minus C. Okay, then 2C minus 2C, that is 0. Again, third column minus first column, C3 minus C1. So we get 1 minus 1, that is 0. 2B minus 2B, 0. Then this minus this, so we get minus A, minus B, minus C. Okay, so C2 equal to C2 minus C1 and C3 equal to C3 minus C1. Got it? Okay, now see, using property, see carefully, all the elements of one side of a principal diagonal is 0. See, this is the principal diagonal and all the element upper side of the principal diagonal is 0. So, what is the result? That means 1 into this. Okay, this is the property of the determinant. So, A plus B plus C into minus A minus B minus C into minus A minus B minus C into 1. So what is the answer? That is A plus B plus C whole cube. Okay, that is the answer. See carefully. Important sum. Now see another sum. Example number 3. This is also important. See carefully. Example number 3. By using property, solve this determinant. Determinant A square plus 1. Okay, A square plus 1, then AB, then AC, then AB, then AC. After that, BA, B square plus 1, BA, B square plus 1, then BC. Okay, and last row, that is CA, CB, C square plus 1. CA, then CB, then C square plus 1. Using property, solve this determinant. Okay, now see how to solve this. First, C1, we multiply C1 by A, C2 by B, C3 by C. Okay, see carefully. So, 1 by A into 1 by B into 1 by C. Okay, multiply first column by A. So, A cube plus A, then A square B, then A square C. Okay, multiply second column by B. That means A B square, then B cube plus B, then B cube C. After that, multiply third column by C. So, A C square, B C square, C cube plus C. Okay. So, multiply first column by A, multiply second column by B, multiply third column by C. Clear, everyone? Now, take now take A as common from the first row, B as common from the second row, and C take common from the third row. See what happens? So A, B, C divided by A, B, C. So in first row we take A as common. So here is A square plus 1. Okay. Then B square, then C square. After that B as common. So A square, then B square plus 1, then C square. After that take C as common. So A square, then B square, take C as common. That means here is B square C, not B cube. Here is B square C. So B square, then C square plus 1. Okay, I repeat. Take A as common from the first row, take B as common from the second row, take C as common from the third row. Okay, now see, then we do C1 equal to C1, that means column 1 equal to C1 plus C2 plus C3. Okay, so ABC cancel. So we C1 equal to C1 plus C2 plus C3. So A square plus B square plus C square plus 1, then B square, then C square. After that, A square plus B square plus C square plus 1, then B square plus 1, then C square, then A square plus B square plus C square plus 1, then B square, then C square plus 1. Okay, so what we do? That means C1 equal to C1 plus C2 plus C3. Okay, now A square plus B square plus C square plus 1, that is common on the first column. All the elements is same. So take A square plus B square plus C square plus 1, take common from the first column. So we get A square plus B square plus C square plus 1. Okay, then 1 1 1. After that B square, then B square plus 1, then B square, then C square, then C square, then C square plus 1. Got it? Now see. Okay, now see. Then we do R2 equal to R2 minus R1. Okay, now erase some part. Now see. Okay, R2 equal to row 2 equal to row 2 minus row 1, row 3 equal to row 3 minus row 1. See what happened? A square plus B square plus C square, A square plus B square plus C square plus 1. Okay, then R2 equal to row 1 is same, that is 1 B square, then C square. After that 1 minus 1, that is 0. B square plus 1 minus B square, that is 1. After that C square minus C square is 0. Then row 3 minus row 1. So 1 minus 1, 0. B square minus B square, 0. Then C square plus 1 minus C square, that is 1. Okay, now see what happened. R1, R2 equal to R2 minus R1. R3 equal to R3 minus R1. Okay, I repeat. R2 equal to R2 minus R1. R3 equal to R3 minus R1. Okay, now see again. Principal diagonal here 1 1 1, and all the element beside under principal diagonal or one side of the principal diagonal, all the element is 0. So what is the answer? 1 into 1 into 1. So we get a square plus b square plus c square plus 1 into 1 into 1 into 1. So the result is, answer is a square plus b square plus c square plus 1. A square plus b square plus c square plus 1. That is the answer. Okay. See carefully. Thank you, students.